Okay, so this is the last lesson of the chemistry unit. We're going to talk about the periodic table. We're going to look at how the periodic table is broken down into metals, nonmetals, and metalloids, and we're also going to look at the different chemical families of the periodic table. Okay, so the periodic table was developed by a Russian chemistry professor, Dmitry Mendeleev. Had 63 known elements, and there was actually many different spaces that were left on the periodic table because it was known that more elements would be discovered in the future. Arrange elements according to mass first. So elements were arranged in rows based off of the atomic mass. Okay, and then based off of similar properties in columns. Okay, so elements that are in the same column have very similar physical and chemical properties. So for example, this column here, okay, so from top to bottom, this vertical column, all of those elements have similar properties. Okay, and then again, arranged by mass. So hydrogen being the first element on the periodic table, and then to helium, and then to lithium, and so on, arranged by increasing mass. Okay, so how the periodic table is structured. So there are 18 groups on the periodic table. Those are known as like the vertical columns, so from like top to bottom. Elements within the same group or same column have very similar physical and chemical properties. So all the elements in the second group on the periodic table are going to have similar properties. There are 7 periods, which are the horizontal rows of the periodic table. Elements in the same horizontal row, we've learned in the past that they all have the same number of orbits, and they're Bohr-Rutherford diagrams. The elements are in numerical order in the periods based on their atomic number. The periodic table can be split into 3 sections based on their properties. So the periodic table is made up of metals, nonmetals, and metalloids. Metalloids are elements on the periodic table that possess properties of both metals and nonmetals. Okay, so again, this is just to reiterate that difference between groups and periods. So these numbers are the group numbers, okay, so 1 through 18. Okay, so elements within the same vertical group. So from top to bottom, all of these elements are in the same group. They're going to have similar properties, okay? Whereas elements in, let's say, the same row, okay? So sorry, that would be like these numbers. We have 7 periods or horizontal rows. All of those elements are in the second row or the second period, and they have the same number of orbits. Okay, so let's first look at metals. They are located on the left side of the periodic table. Okay, so they are left of the staircase, and I will show you this on a diagram shortly. Metals are good conductors. They have the ability to conduct electricity. They're very lustrous. So when we learned about luster, we learned that that means that they have the ability to reflect light. So metals tend to be very shiny. They produce colors when heat is applied. They're malleable. Okay, so they have the ability to bend. They are ductile. They have the ability to be drawn into long, thin wires. And this includes the transition metals that are found in the center of the periodic table. Nonmetals are found to the right of the staircase. They are insulators, so they're not good at conducting electricity. If they're solid, they're brittle, so they're non-malleable. They don't have the ability to bend. They lack luster, so they tend to be dull. And they're typically gases, powders, and solids. And the nonmetals include hydrogen. Okay, so all the nonmetals are on the right of the staircase, with the exception of hydrogen. Metalloids are found along the staircase. they, like I said, have properties of both metals and nonmetals. Okay, and then there's the list of them there. So if you guys look over here, all of the elements in green, those are metalloids, so that are circled with that red color there. Those are all metalloids, okay? To the left, so all of this yellow are metals. Okay, so all of the yellow represents metals to the left of the staircase. Okay, and when we say staircase, guys, that's like this thing here. Metalloids are along the staircase. Metals are to the left of that. This includes these guys here, which we call the transition metals. And then to the right of the staircase are the nonmetals. So in blue are all nonmetals, including hydrogen. Okay, on your classification of the elements worksheet, color in the following on the first periodic table. So this is just reiterating exactly what I just showed on the last slide. All the purple are elements that are metals. And then just in this little space right here, the middle area, those are transition metals, but still metals. And then along the staircase, over here, we call those metalloids, the green, and then to the right of the staircase in yellow are our nonmetals plus hydrogen. So now we're going to talk a little bit about chemical families. So these are groups of elements in the same vertical column. They have similar physical and chemical properties. So you'll see on the periodic table here, we have elements within the same group. So keeping in mind, this is like the first group, second, all the way over here is group 17 and group 18. So the alkaline metals are all the elements in this first group, so group number 1, they have similar properties. Alkaline earth metals are in the second group, similar properties. Okay, transition metals, similar properties. Halogens, 17th group, have similar properties. And then the noble gases in the 18th group all have similar properties. Okay, so this is just to reiterate again the same thing on the periodic table. This very first group here, with the exception of hydrogen. Okay, so actually, with the exception of hydrogen, are our alkali metals in purple. Then we have our alkaline earth metals. Over in the yellow column, we have our halogens. And in the last 18th column, we have our noble gases. Okay, so, lithium, sodium, potassium, all in that first column and so on, they all possess the same or similar properties. So let's begin with the alkali metals. So that's these guys down here. Okay, so first group on the periodic table, minus hydrogen, so group 1. These guys are the most reactive metals, and remember, these are metals because they're to the left of the staircase. They're shiny in luster, silvery in color, soft in terms of hardness. They have low densities, okay, so they're less dense, and they're found as compounds in nature. So an example would be salt. Okay, salt is an alkali metal. It is made up of sodium and chlorine. Next, we have our alkaline earth metals. So this is group 2. Okay, so all of these elements in the second group here are the alkaline earth metals. They are reactive, but not as reactive as our alkali metals. They're less reactive. They're also shiny in luster and silvery in color, but these guys are stronger metals. They're not as soft. They burn brightly and are colorful. So this is a nice real-world application here. It'd be alkaline earth metals that are involved in fireworks, okay, because they burn brightly. An example would be magnesium. If we were in class, I'd be able to take a piece of magnesium metal, put it in the flame, and when heat is added, it produces this really bright light. Next, we have the halogen gases. So this is group 17. So these guys over here. They are the most reactive non-metals. So remember, now we're over to the right of the staircase. So we're dealing with metals now and the halogens. Very characteristic medicinal qualities. Okay, so some medicinal qualities there, often found as compounds, commonly salts. So sodium fluoride is in toothpaste. Occurs as gases, liquids, and solids. And when combined with hydrogen, they become acids when dissolved in water. Okay, so an example would be fluorine. Lastly, we have the noble gases. So that's these guys. In this last column here, this last group, 18, they are very unreactive. So noble gases in their valence shell is always full. So we learned in Rutherford diagrams that the valence shell is the last orbit that contains the valence electrons. So the noble gases have a valence orbit that's always full. And because it's always full, this causes them to be unreactive or stable because it's those electrons that take place in chemical reactions. They are gases at room temperature and colorless, odorless, tasteless, and an example would be neon lights. Neon is an element in the noble gases. Lastly, here we have hydrogen, the group of one. So that's our hydrogen over here all on its own. Hydrogen reacts readily with alkali metals and halogens, but also many different elements. So hydrogen just tends to react more with our alkali metals in group 1 and our halogens in group 17. Hydrogen is a non-metal. It's also odorless, tasteless, and colorless, which are our physical properties of odor, taste, and color. And then it's also highly flammable. Okay, so it's combustible. It has the ability to burn. Okay, and it does not really fit into the periodic table as it possesses too many properties similar to many elements. Okay, so that describes metals, non-metals, metalloids, and our 4 main chemical families on the periodic table. You guys have a little bit of practice on pages 31 to 32 in your booklet.